Hello, and welcome to Backer Breaks It Down. In this episode, we are going to look at proofs with parallel lines. Right. So, I just want to review the transitive property of congruence because it's been a while since we've last seen this property. When I introduced this property to you, like a month ago, maybe longer, I did so with this cartoon. And it says, kerosene is fuel, Brian. Red Bull is fuel. Kerosene is Red Bull. And this illustrates the transitive property because what we notice is that these two, like kerosene is fuel, Red Bull is fuel. So kerosene and Red Bull, since they're both equal to fuel, that means that they're equal to each other. So kerosene is Red Bull. And this illustrates what the transitive property is saying. Okay, now the transitive property can be used with angles or segments. Since we're going to be working with proofs involving parallel lines, we'll definitely be working more with angles here. So you can have angles congruent to the same angle, and that's kind of like what the cartoon is illustrating, because kerosene and Red Bull are both equal to the same thing, that being fuel. Okay. Or you can have angles congruent to congruent angles, and that makes them congruent to each other. Okay. So let's see the transitive property in action in a proof. Okay. So here we're given Km bisects angle JKL, Kn bisects angle MKL, and we want to prove that angle 1 is congruent to angle 3. So basically, my goal is to prove angles 1 and 3 are congruent, which means that angles 1 and 3 need to be part of my proof. And right now they're not. Right now, all I have are like the two givens. Okay. So let's see how we can use the given information to bring angle 1 and angle 3 into our proof. So examining that first item, they say that Km bisects angle JKN. So if we look at our diagram, and we locate angle JKN, what can we conclude? Exactly. We can conclude that angles 1 and 2 are congruent according to the definition of bisects. Let's write that down. Angle 1 is congruent to angle 2, and the reason is definition of bisects. So what about that second given, right? So we're given that Kn bisects MKL. So what can we conclude? Exactly, we can conclude that angle 2 is congruent to angle 3. According to the definition of bisects. So we have drawn our conclusions from the given information. Angle 1 is now part of our proof. Angle 3 is now part of our proof. So the question is there enough here to prove they are congruent to each other? Yeah, you're exactly right. There is plenty here because notice they are both congruent to angle 2, making them congruent to each other. So kerosene equals Red Bull, right? So that's our transitive property. Okay. So now let's bring our parallel lines and the angles associated with them into this lesson, okay? So we have 5 postulates and theorems involving parallel lines, okay? the alternate exterior angles theorem, the alternate interior angles theorem, and the corresponding angles postulate will prove that these angle pairs are congruent to each other. The same side interior angles theorem and the same side exterior angles theorem will prove that these angle pairs are supplementary to each other. Okay. So in this problem here, our goal is to prove the alternate interior angles theorem. Okay, so whenever we prove theorems in geometry, we are not allowed to use the theorem in our proof. Okay, so what that means is that we cannot use alternate interior angles in our proof. Okay, now we are given that line P is parallel to line Q, so we can use like those other postulates and theorems associated with parallel lines. We just cannot use alternate interior angles are congruent. Okay, our goal is to prove that angle 1 is congruent to angle 2. So how can we use the information we're given and or the diagram to do this? Okay, keeping our eye on the prize, so to speak, we need to bring angle 1 and angle 2 into our proof. Okay, so if you know, when you look at angle 1 here, you could be like, well, you know, angles 1 and 3 are corresponding angles, right? And according to the corresponding angles postulate, they'd be congruent to each other. Okay, so we can say that angle 1 is congruent to angle 3 by the corresponding angles postulate. Right, so angle 1 is in the proof. Way to go. Now, how can we bring angle 2 into the proof? That's right. Angles 2 and 3 are vertical angles. So we can state that. So angle 2 and angle 3 are vertical angles. And our reason for that is assumed from diagram. Pardon my messy handwriting. And then what should we immediately follow that up with? Exactly, they're congruent to each other. So angle 2 is congruent to angle 3 because vertical angles are congruent, right? So now angle 2 is in our proof. So both of the angles that we're trying to prove are congruent are in our proof. In step 2, we said angle 1 was congruent to 3, and in step 4, we said angle 2 was congruent to angle 3. So why are angles 1 and 2 congruent? That's right. Yikes. Oh my goodness. But transitive property is correct. All right, let's take a look at one more. In number 4 here, we're given that line A is parallel to line B and that line C is parallel to line D. Our goal is to prove that angle 1 is congruent to angle 4. I'm sorry, is supplementary to angle 4. So here's angle 1, here's angle 4. We need to bring both of those angles into our proof using what we've been given and or the diagram. So what are some thoughts? Okay. So we're noticing that angles 1 and 2 are vertical angles and thus they are congruent. So let's throw this in here. So angle 1 and angle 2 are vertical angles. And the reason for that is assumed from diagram. And then we could say they're congruent to each other because vertical angles are congruent. Right, so angle 1 is in our proof. What about angle 4? Okay, yeah, we could be like 3 and 4 are congruent because they're alternate interior angles. So alternate interior angles theorem. Okay. What about supplementary? Like, I feel if I'm going to prove that angle 1 is supplementary to angle 4, then I probably need supplementary somewhere in my proof. Yeah, I mean, like 2 and 3, they would be supplementary because of the same side interior angles, right? So we can say that angle 2 is supplementary to angle 3, same side interior angles theorem. So we basically have like all 3 pieces. So angle 1, angle 4, and supplementary, it's in our proof, okay? So here we have like angle 1, here we have angle 4, and here we have supplementary. So why is angle 1 supplementary to angle 4? Well, yeah, I mean, like I could, since I know angles 3 and 4 are congruent, I could replace angle 3 with angle 4, right? So angle 4. And yeah, I could like do the same thing here. Since 1 and 2 are congruent, I could replace angle 2 with angle 1. So I can make this replacement of these congruent angles in, into statement number 5 to create angle 1 is supplementary to angle 4. And what this is called is substitution. Sorry. Substitution, because like, yeah, we replaced angles 2 and 3 with angles they were congruent to. So we made a simple replacement. And so this is similar to when we use substitution in algebra. Okay. Just one word of caution. You never will use substitution to prove congruence. Okay. If you're thinking that, you're most likely thinking about the transitive property. We use substitution in a scenario like this where we're proving like a different statement and not a congruent statement. Okay. So that's how proofs and parallel lines, like how they're all connected. So we have these 5 theorems and postulates that are on your reasons sheet that we can use anytime that we're given parallel lines. So you have to be like given line L is parallel to line M or however they're naming them, right? But if you're given parallel lines, you can use any of these theorems and postulates, well, that apply to the situation, okay? And that's how Bakker breaks it down.